Let's create a generative tuplet sequencer. So what is a tuplet? It's when we divide a beat into a different number of equal subdivisions. An example will explain this much better. We have a quarter note here and we can subdivide it into 3 notes. So in the same amount of time that one quarter note is played, there will be 3 notes. And this is called a triplet. We can of course subdivide into 5 notes if we wanted to. And this is called a quintuplet. It doesn't sound that musical if we play all 5 notes, so let's create a pattern. We get that J Dilla or Lofi hip-hop type beat happening. Odd number tuplets are great for creating interesting grooves. Here's a list of all the tuplet names. Okay, let's create a tuplet rhythm in pure data. So, in this video, we're going to walk through this patcher and dissect what's going on in each part. After downloading the patcher and turning the DSP on, we can click here to turn on the sequencer and hear the patcher in action right away. And this right here will turn on and off the generative feature. We'll talk more about this later. Before diving deep into each part of the patcher, let's talk about what it does overall. The patcher is divided into 2 main sequencers. Sequencer number 1 plays a hi-hat in tuplet patterns. And we can choose the number of subdivisions. By default, it's in septuplets, a division of 7. And we can subdivide up to non-tuplets, which is a subdivision of 9. And we can either manually or generatively create a pattern. As for sequencer number 2, it is playing a quarter note kick-snare pattern, also known as a backbeat. Keeping it simple with this sequencer. Again, this is what it sounds like together. Okay, let's start out by looking at the BPM algorithm. So we can change the BPM with this number object. By dividing 60,000 milliseconds by the BPM value, we get the length of time of one quarter note. Let's first have a look at sequencer number 2. Again, this is the simple quarter note backbeat sequencer. And I'm going to disconnect this for now. This right here is a counter algorithm. The counter increments by 1 for every quarter note length of time. And by using a modulo right here, this number object goes from 1 to 4 and it keeps on looping. And that looping number is sent to the backbeat sequencer right here. By the way, the counter resets when the sequencer is turned off. The counter algorithm for the tuplet hi-hat sequencer is pretty much the same except for these 2 parts. So this is where we can choose the number of subdivisions. For example, if we change this to a 5, the quarter note time is divided by 5, which gives us the length of each quintuplet note. And the modulo right here is changed to a 5, so we get a loop of 1 through 5. By the way, this update right here will make sure that this number will change every time the subdivision value is changed. And this is the tuplet sequencer. I'm going to delete these for now to make it cleaner for this section of the tutorial. We can manually set the pattern by using a toggle object that is connected to a gate object. Okay, let's play around with the different subdivisions. Finally, let's talk about the generative feature of this patcher. So let's connect this here again and put this back. Let's generate a new pattern every one measure, which is equivalent to 4 quarter notes in 4/4 time signature. So these are the pattern generator algorithm. It's using a random number generator, probability, in the gate to decide if a note is played or not. And the bang message is sent from here. So after the quarter note is played 4 times, a bang is outputted. And that bang message is delayed by almost a quarter note. So the delay time is the length of a quarter note, but shorter by 10 milliseconds. A new pattern is generated right before the start of the second measure. This is to avoid an issue where the first note of the previous pattern will play at the same time as a new pattern is generated. I'll put an example right here to hopefully explain this better. We didn't have to do it for this particular patcher because the first note will always be played 100% of the time. But this technique will come in handy if you are randomizing the first note. And we can choose to turn on and off the generative feature by using the gate object. Okay, let's hear this in action. Alright, we have a complex beat generator that should spice up your algorithmic music projects. Okay, what's next? Well, tons actually. Here's some stuff that we could try out. We could add a generative melody patcher, for example. We also could use the Tuplet sequencer with the kick sample instead of the hi-hat. Or maybe use it for melody or bass line. And we could also send these drum patterns as MIDI notes to our DAW of choice. And because we're using BPM, we could also record the drums and then layer sounds on top of it. So many possibilities. Alright, download a patcher and have fun.